My name is Mary Kirtland, and I get paid by Microsoft to think about writing applications using components, which is really pretty cool when you think about it. If anyone ever figures that out, they'll probably make me do some real work. But for now, I'm having a lot of fun. Mostly what I do is go out and talk to people about the things that I've been thinking about writing applications. And this is an extremely recent snapshot of my thinking, circa 7 a.m. this morning. So what we're going to look at is an overview of some application architectures, things that you can do with COM+, present some rules for good design, and then talk about some specific design patterns for COM+ in terms of those rules. Also point you at some resources you can use for further information, and we should have some time for Q&A at the end. So I'm sure you've seen this slide thousands of times. You're going to see it thousands more times. Windows DNA, we've been talking about it for a couple of years. It's the basic application architecture promoted by Microsoft. And it is a 3 logical tier architecture, 3 layers: presentation, business, and data logic. One of the complicating things about Windows DNA is that we provide a lot of choices within the realm of what do you do at the presentation layer, what do you do at the business layer, and particularly as you get toward the data end of things. And it makes it hard to figure out exactly how you should build applications. So one of the things that I want to talk about is the ways that you can go about narrowing down those choices and making specific recommendations within your particular set of circumstances in your project so that you have a consistent way of looking at data or a consistent way of moving data to the presentation tier. Now the COM+ services, they mostly interact at the business logic level. That's what they are positioned for. And so this is the primary focus of this talk, is things that you would do in the business layer. And we'll overlap a little bit into the presentation layer and the data layer, primarily from the standpoint of what do you have to do in your interface to make sure you can pass data back to the presentation layer efficiently, and how do you get the data out of the data layer in the first place. So the objectives for this talk are to look at some common architectural styles, and we'll discuss a little bit more what that is. Describe some things that you would want in an application architecture, and then look at some specific patterns that are related to common requirements. This is by no means a comprehensive set of all the things you would need to do in a COM+ application or any DNA application. I just picked a few things that I thought we could talk about within the scope of an hour. And there are a lot of assumptions made here. The first is that you understand basically what the COM+ feature set is, that you know basically what queued components, events, load balancing, IMDb are. It also assumes that you understand the basics of the programming model for MTS and COM+, which are basically the same, and understand something about the process of 3-tier design. This talk was intended to be a follow-up to another talk I'm doing later this week on Thursday. Unfortunately, the scheduling gods didn't cooperate, so we're doing this one first. If you find that there's some things that you need some more background information on, I would encourage you to come to the Thursday session, which is called Designing Complex Applications. That's going to focus more on the process and how you move from a logical design into a physical implementation design. There are also specific features or specific sessions on individual COM+ features, and those sessions are going to go more into how you write code for a particular feature and where you might use it in specific circumstances. So if you want to look in more depth at a particular feature, I would encourage you to go to those individual sessions. Another thing I wanted to point out is that there's going to be a lot of sessions here at TechEd that discuss designing applications in one form or another. And they may not all say exactly the same thing. That's okay. There is no one right answer for designing a 3-tier distributed component-based application. There are lots of bad answers, and hopefully I won't tell you any of those. And there are some good enough answers. Good enough meaning it's good enough for the particular circumstances that you are building your application for. So I hope that this presentation is a snapshot of some good enough answers that you can apply in specific situations. And that as you go to other sessions at TechEd, you'll find other specific patterns and scenarios that you could apply in other parts of your application. If you're having trouble figuring out when to use a specific technique or specific pattern, I encourage you to think about the characteristics of the solution that are most important to you. Is scalability the most important? Is ease of development most important? Is maintainability the most important thing? Do you expect to have a lot of change in your application, so flexibility is very important? And when you've determined what characteristics are most important to you, you'll probably find that some of the patterns you can throw out. They aren't appropriate for your particular situation. If you still have multiple choices, I would encourage you to do some experimenting. Take a particular use case from your application that has a representative type of data, the typical volume for your application, typical format of data, and just write a little application to try out the various alternatives. This will give you a good feel for what the techniques can do and where they start to break down, how difficult they are to implement. And you'll find that over time you'll build up a good repertoire of techniques that you can use for your three-tier applications. So with that, I want to show you a couple of definitions. The first is for architecture. I really like this definition. It gets the point across exactly. The set of design decisions about any system or smaller component that keeps its implementers and maintainers from exercising needless creativity. You don't want people getting too creative. This is from a very good book called Objects, Components, and Frameworks by D'Souza and Wells. I've got this listed as a reference at the end of the slide deck, but it's a very good book about component-based architectures. And in that same vein, I offer this definition of a pattern, a structured document with a catchy title, that's very important, describing a good practice, usually in excruciating detail. I read quite a bit of patterns literature over the past couple of months, and there's like one sentence that really gets the point across, and if you know what that means, the rest of it is just, you don't care. So the main thing about patterns is what they're intended to do is to capture good practices and document them in a way that the people who don't know them, who don't understand them, can go and learn from the expertise of the people who develop them. So if you've been doing development for a while, a lot of these techniques are going to sound very familiar. And that's good. That means that somebody has used them before and they actually worked. If they don't work and you know they don't, please let me know so I don't tell any more people about them. So let's look for a couple of minutes at application architectures. And the first thing I want to talk about for a little bit is why you want to do architecture in the first place. Well, the applications we're developing are very complex. And particularly with a component-based application, you end up with many pieces. And they're spread out over multiple computers. Because of that, it's important that you don't let people exercise too much needless creativity. If you have a team of people working on the project, it's really important that the interactions, the interfaces between the pieces of your application stabilize pretty early on. This way, people can rely on the interface and they can code to that interface. They can write test cases around the interface so that they don't need to rely on everyone else's components in order to work on theirs. Architecture is an important aspect in defining the building blocks and the interfaces between them. You also find that if you let people make decisions at a component level about things like how to handle errors, how to name methods, how to pass data around, how to do security, every developer is going to do it a little bit differently. And that can make hooking the components back together into an application really tough. So if you provide some guidance up front in your application architecture, and over time if you develop an enterprise-wide architecture, then you eliminate the need for making that choice at a per component level, and you get some consistency across your components. This makes them easier to reuse and easier to assemble into an application. Some common styles that you'll see in applications, not necessarily COM applications, but any applications at all, are peer-to-peer. This is very common in object-based programs where you have a lot of objects or components that are cooperating. They pass messages back and forth, but there's not really any one in particular that's in charge. You'll also find this when you're having applications that are integrated. So each application will have its own style. They communicate between each other in a peer-to-peer fashion. You may also find a broker style. This is where you send requests to one particular component or one object, and it hands those requests off to many other objects. A style that isn't quite as common in the COM world is a pipe and filter style. You see this in Unix command line programming where you're tying together a bunch of individual commands. The commands at the DOS command line, if you remember those, many of those could be piped together. Another place where it is used in COM is in the DirectX architecture. So this is something where you have a set of filters and you hook them together using COM interfaces as the inputs and the outputs. And for situations where you have a set of processing that you have to do in some order, but the order is not intrinsic to the operations themselves, pipe and filter-based architectures will work very well. Another style is the event-based architecture. This is the basic Windows application programming model. There's a set of events that you can capture, and in response to those events, you do work. And in highly distributed applications, event-based architectures are very common. You don't necessarily want to tie things together as tightly as you typically find in a layered COM-based architecture where the layers at the top understand exactly what classes of objects they need to call at the next lower level. Sometimes you need a more loosely coupled system, and an event-based architecture is very good for that. Of course, the one that we promote with Windows DNA is a layered architecture. There's many variations on this. I want you to just keep in mind the color coding for presentation, business, and data. I use this later on in some examples of patterns. So blue is a presentation, blue is presentation, orange is business, green is data. The key thing about layered architecture is that each layer depends on the public interface of the layer below. It can't typically drop all the way through to the lowest layers, and you don't usually have a lot of interaction that spans more than one level. There are many variations on this, and I want to show you a couple of examples that are very common in COM-based programming. The first is kind of the prototypical simple COM application, where you have a Win32-based or native application that uses DCOM to talk to some objects that are running usually on a separate machine within a COM+ environment. This same architecture applies to MTS. So the presentation layer will talk to one or more business objects, and those business objects in turn use COM or DCOM to communicate with the data objects. The data objects would use a mechanism such as ADO to talk onto the data store, for example, SQL Server. Another very common example is a web application that uses active server pages, where you have some client-side presentation code that is generated by active server pages running under IIS. And those pages can be generated using server-side script. And that script can in turn call business objects that are running within COM+. And those again call data objects and talk to data stores. So that's kind of the basic standard 3 logical tier layered architecture for Windows DNA. What you usually find in big applications is that you will have layers within a particular application, but you'll also find a mix of other styles. That sometimes it will be appropriate to have peer-to-peer communication, say between apps. In other cases, you may have a need to do event-based programming within a particular layer. You might need to do some sort of pipeline programming within a layer. So there's many variations, and what you develop over time is this set of techniques that you can use and an understanding of where you might apply them. So some of the key aspects that you would want to include in an application architecture specific to a particular project would be some different views of your application. The conceptual view is the use case mapping to the big building blocks in your application architecture. This gives you some level of traceability. You want to make sure that you know how to get to particular component, or you need to know where particular requirements come from and how they're implemented within the architecture. If the requirements change, that way you know what components of the architecture might need to be changed. You also want to have some logical view. This is, again, the big building blocks, the basic structure of the application, not relative to particular source code files, for example, or particular deployment of components, just basically what the components are. That's what basically we showed you in the previous diagrams. You'll also want to see some physical deployment diagrams, what machines you have available to deploy your application on, the constraints on those. For example, if you have to communicate via HTTP or you're outside a firewall for a particular part of the application, and how you can deploy the logical elements of your architecture across those machines. You'll want to get some indication of how you can communicate between them and the requirements for quality of service, for example, on the communication links. So that's just basically standard design architecture type stuff. Some of the things I think are really important to do when you're doing component-based architecture in particular are to come up with some strategies for common tasks. These are things that you want to be the same across your application, or at least you have a small set of options across the application. The first is about naming. You want to have a fairly consistent programming model for your components. You want to make sure that you have standard ways of naming methods, that you have standard ways of exposing an object model, whether you use multiple interfaces per class or whether you just use one interface per class. You want to have some recognizable pattern to that. That makes learning about your components easier. You also want to have a well-defined strategy for managing state within the application. Are you going to keep it on the client? Are you going to keep it on the server? Are you going to keep it in the database? Where are you going to pass it around? When do you need to pass it around? This is particularly important when you're working with MTS and COM+, because COM+ and MTS as well will not let you maintain per object state across the transaction boundary. So the in-memory state for a particular C++ object, for example, a particular COM object, is going to go away when you end a transaction. If you have non-transactional objects, that's not necessarily the case. The state will stick around, but it's something you need to be very aware of when you're working with transactions in COM+. You should also have a strategy for how you're going to move data around the system. You don't really want to be converting data from one format to another format as you move between components. You want to be able to keep it in one format. You want to have some standard recognizable ways of moving the data back and forth, common patterns to the interfaces for moving data around. It's extremely useful to have a common strategy for security. Are you going to use NTLM or Kerberos integrated security, or do you need to have a separate login that's private to your application, or some application-specific security mechanisms? Now, there's a two-part talk on security that is going to cover several patterns later this week, and so I'm not going to spend a lot of time talking about kind of the basics of security, but I would encourage you to go to that talk and listen to the security experts spend 2 hours discussing that very topic. Another thing that is extremely helpful is to have a standard way of doing errors. And you might say, but COM has a standard way of doing errors. It's called iErrorInfo and hresults. Well, hresults only give you a number back, and that's helpful, but it doesn't give you a lot of information you can use to do any sort of debugging or tracing or auditing. And iErrorInfo has this nasty tendency to disappear just when you need it most, particularly if you've been calling ADO code. Don't ask me why. But if you've ever seen that method squiggly of squiggly error, that's what's happened, is the iErrorInfo has been cleared out before it got back to you, which means that no one knows what the error was that happened. Another thing that you want to think about is the monitoring strategy. How are you going to let people look at the application as it's running? How are they going to measure characteristics of the system? And if you have a standard way of providing monitoring information, That will make it much easier for people to monitor your app. And I'm sure you can think of others. Those are just some of the key things that I think most applications are going to need to have some strategy for. So this is my top 11 rules for good design. I can't exactly figure out how I ended up with 11, but here they are. The first is to use a consistent component style. We're not really going to talk about this too much. That's kind of the point of doing design patterns in the first place, is that you come up with some styles for writing your components and your component interfaces. You want to program to the interface, not to the implementation. And you might say, well, that's just what COM is all about, right? I can't see the implementation. All I use is the interfaces. You'd be surprised how often people actually end up going to look at an implementation or testing the implementation to see how it reacts when you call a particular method, and end up with some embedded dependency on the particular implementation in the caller's code. That's something you want to try to avoid. You want to favor loosely coupled systems, and there's a couple aspects to this. One is providing narrowly scoped interfaces. Promote low coupling through a narrow, well-defined interface. Don't have kitchen sink interfaces that provide thousands of methods on them. Another aspect of that is deferring decisions about what object to create, what class of object to create, to a third party. So you're not tied to a particular prog ID or a particular class ID. Someone gives you that information. Encapsulating variation is a very powerful technique, and it's one of the ways that you can avoid the issue of inheritance and the lack thereof in COM. So typically when you're building an application in C++, for example, or Java, you would implement some base class and it would have some set amount of built-in functionality. Then you would inherit from that and override certain methods. The problem that you have there is that it's really hard to figure out exactly when you need to call the base class method. So if you can turn it upside down and provide a common implementation that then calls into a separate class that you create, and that class only implements the differences, the variability, then your common behavior is controlling exactly when those particular variable methods are called, rather than you having to try to figure out when the methods of the base class should be called. And we'll look at an example of that in a couple of minutes. You want to implement behaviors in one place. You don't want business rules copied multiple places because they're sure to change, and then you'll have multiple places to change. This is also related to the previous thing of if you have a standard flow of control, only put that in one place. Don't rely on subclasses or extended classes of COM objects to delegate back to a common generic object at the right time, because they probably won't. So those are all just kind of basic good design techniques that you would use regardless of whether you're using COM+ or Windows DNA or not. These techniques are things that are more specific to distributed apps, and particularly those using COM+. The first is stay off the wire. Don't use more network bandwidth than you absolutely need to. One of the key things that you can do when you don't think about distribution and you're building your app is you end up with interfaces that are property-based. And then you use them in a distributed scenario, and you have clients calling over to a server machine and getting back 1 byte of data at a time, or 2 bytes of data. This is very bad. You want to get a bunch of information in one method call and try to avoid a lot of chatty traffic between your components that are on different machines. Related is that you want to make efficient use of resources. One of the key benefits of the 3-tier design is that you have presentation objects. Instead of holding connections to databases, for example, directly, they talk to business objects that can share those connections across multiple users. But within your business objects, you do need to make sure that you're not holding onto those resources for a long time, that you use them and then you throw them back in a pool for other people to use. And this lets you get a lot of essentially multiplexing across multiple clients and gives you very good efficient use of resources. Convert your data judiciously. You don't want to be converting between row sets and record sets and variant arrays and XML and beasters and whatever else, because different people have implemented interfaces differently. Try to keep the data in one format for as long as possible and then convert it when you need to. You also want to try to provide data in strong types as much as possible rather than sticking it in variants, because then every time you access the data, it needs to be pulled out into a particular type format. Remember who your clients are. This is something that's really important today in COM, because there is a difference between a script type client that accesses information through iDispatch or very late binding, and a client that understands more about the COM mechanisms of query interface and interface specific behavior. If you know that your clients are script clients, you have to take special care to provide the functionality they need through an iDispatch interface. And that can lead to all kinds of weirdness in the object model you end up providing to your clients. So you need to make sure that you keep track of who the clients are. You also don't want to get too carried away and design a solution that's so general purpose that it would apply to every client that might ever come along. It's a good idea to design your solutions for the clients you know about, and maybe one or two that you expect to be coming down the road shortly, but don't try to make your components all things to all people. You want to remove time-independent work from the critical path. This is something that Qt Components in COM+ is very good for. And there is a talk specifically about COM+, about Qt Components. So I'm not going to talk about that a lot. I'm going to have one scenario where this is used. But the basic idea is, instead of making a synchronous COM call like you do today, the only thing you can do, you would queue a message that says, I want to do this work eventually. It doesn't have to be done right now, but eventually I want the work to be done. And the nice thing about Qt Components is it makes that look like COM method calls to the sender and the receiver. And finally, you want to avoid single points of failure. This is another one I'm not going to talk about here because it's not necessarily so much a thing where you have to design your components differently, except that you want to be able to take advantage of load balancing, and you want to be able to take advantage of clustering. So you need to watch out for machine affinities. And again, there is a talk specifically on the load balancing and clustering aspects of COM+, so I would refer you to that talk for more information about avoiding single points of failure. So those are 11 possible rules. I'm sure you can think of more, but those are the ones I could think up at some god-awful hour this morning. These are the design patterns I want to go through, and some of them you'll recognize probably as standard design patterns, and I'll talk about them from the standpoint of how they would be used in COM. Others are more specific to COM+, and hopefully we'll make it through all of them. The numbers in the brackets are references back to the rule numbers. So these are the specific rules that are used in this particular pattern. So the first one is a facade. The key thing about a facade is that it provides a simplified view of an interface into a subsystem. So instead of having your presentation layer, for example, talk to all of the different objects in the business layer, you provide a simplified view in a facade object, and the presentation layers can talk directly to that. The facade can in turn call the other objects in whatever complicated object model has been provided by that subsystem. Now the power users, the people who understand the complexities of the system or need more capabilities, can still get to the underlying object model. But for the clients that don't absolutely need all the power, they can go through the facade. This is a really great way to deal with the script client, who may just need a simplified set of functionality. So you give them a facade, it implements iDispatch, they use that. Anyone else can use your nicely factored COM objects with multiple interfaces that are optimized for early binding. Another factory that's a standard design pattern that you can use is the abstract factory. Usually, when you create objects, you specify the name of the class that you want to create within the calling object. And sometimes this isn't a good idea. You don't want to be that tightly coupled. So what you can do is hide the knowledge of which class you need to create in some third party called an abstract factory that provides methods that are like create this kind of object and create that kind of object. And it will figure out which of several possible implementations to return to you. This is really a useful technique if you have to do customization work and you might have multiple implementations of a particular object and you don't want to hard code the class names or prog IDs or class IDs within your calling applications. So the basic idea is the calling component will call down into this abstract factory and ask it to create an object. It will create a specific instance of an object and hand the interface pointer back. At that point, the calling object just calls directly to the object that has been created. Another standard pattern that you can use to reduce coupling between your caller and callees is to use the observer pattern. The observer pattern is also known as publish and subscribe. And you can implement this using COM+ events, which are a new thing in COM+. If you need the same kind of thing on MTS or NT4, it's fairly easy to implement this kind of pattern yourself. But basically what happens is that you define an interface which describes the kinds of events that can be fired. And the caller publishes information by calling methods on that interface. But it's not really calling specific objects. It's calling into the COM+ event system that turns around and passes those calls on to parties that have subscribed or objects that have subscribed to those events. The nice thing about the COM+ event system is that subscriptions can be persistent. So you don't have to have running objects in order to create a subscription. You can say this type of object wants to subscribe, and when the event system gets an event, it will create an instance of the object and pass the event off to it. So that's very useful when you need to do things like broadcast information to an undeterminate number of possible interested parties. It's also useful when you don't want to have tight coupling between the sender of information or the publisher of information and possible receivers. Another pattern that you can use for reducing coupling between applications in particular is to use a combination of facades and adapters. So it's very common these days to need to integrate two different applications, and you can't always rely on being able to change the code in either one of them. So what you can do instead is to implement a translation layer. The translation layer uses either a facade or an adapter or a combination of the two. The facade provides one entry point into the application, simplified entry point into the application, and the adapter is used to convert, say, between COM and some other technique. So it converts between one interface and another. It doesn't necessarily mean a COM interface. It could be an MQ-based interface. It could be some sockets-based interface. It doesn't really matter as long as you have an adapter that talks the facade-provided interface on one end and the other application-specific interface on the other end. So what this might look like, if you have two 3-tier applications, then you might provide facade objects that communicate with the business layers of each one. And when applications need to interact with each other, they communicate through those facade layers. Say you have another application that's been implemented somewhere else, and it relies on a standard, independently determined protocol. Well, instead of requiring that knowledge of that protocol be embedded in your 3-tier application, you can encapsulate that knowledge within the adapter and have the adapter communicate with some adapter logic or encapsulated protocol in the third-party application. The nice thing about doing this, or one of the reasons you do this, is those protocols have a tendency to change, and they also have a tendency to be different depending on different implementations of those applications you're talking to. For example, if you're trying to do something like communicate with stock exchanges, my understanding is that every stock exchange has its own independently developed protocol. So if you want to talk to multiple ones, you have to talk multiple protocols. By hiding that information into an adapter pattern, you remove it from the core logic of your application. I want to spend quite a bit of time talking about data and how you would design data objects and the movement of data around your application, primarily because I get a lot of questions about it. And the first question that I always get is, should I have one data object or many data objects? And the reason this question comes up is that there's two primary Windows DNA application examples that are provided on MSDN. And one uses the approach of one COM class per logical entity in the data model, and the other one uses a generic class. So we provide both options for you and don't really provide any guidance about which one to pick. So I'm going to try to give you some guidance. So the things to think about. The reason I think that most people look at using a generic data object is that most of the code in your methods for creating records or querying records or deleting records or updating records is nearly identical for all of the logical entities. So why not just put all the code in one place? So that would encourage you to say, hey, I want a generic data object. In addition, if you have a very complex data model, then having one COM class per logical entity or per table in your physical structure can become kind of unwieldy. So you might think, well, I'll have a generic object, it'll have all the work in it, and I'll have the business layer pass in exactly what data table I want to connect to, or what table I want to read, what information I want to get, what stored procedure I want to call. Well, that's really great, except now you've exposed the responsibility for making decisions about what data store to use to your business logic. And you might think really hard about whether you want to do that. Usually what you want to have is some data objects that encapsulate the responsibility for keeping the data consistent, making sure you know where it is, the responsibility for knowing what the data store is in the data layer. If you defer that responsibility out to the business layer, you've increased the coupling between the physical data schema that you've got and the business objects that you've created in your system. Depending on your circumstances, that may or may not be a good thing. So I would encourage you to take this approach. Do have one, or start with this approach at any rate. Have one COM class per logical entity in the system. This gives you the ability to change the underlying physical data schema without having to change your business logic, key reason for having data objects in the first place. And then use one of three options for achieving reuse of that standard code. The first is good old functions. You have a library of standard functionality that you can use to implement your particular per object class or per data object classes. In Visual Basic, you have to kind of have a library of functions in a module. In a language that supports inheritance, you can have a base class and inherit from that. Another approach is to have your specific classes delegate down to a generic object. This gives you a language-independent way of encapsulating the basic functionality, so you can really tune that if you want to and provide very fast access to your data through this generic class, but you're still providing a layer that abstracts the knowledge of the data structure from your business logic. And that is probably a reasonable technique. Another technique that you could use is to have a generic class and have the specific classes for each logical table plug in underneath. This is sort of that inversion of the inheritance mechanism. So basically what you have is you have this generic class that has plug-in points. It defines a standard interface for classes that can plug into it. And the business object calls this generic class and passes in the name of the class it wants to create that has the specific information about a particular object. That entity-specific class is created by the generic class, and it's used by the generic class to get specific information like the DSN string or the specific queries that you want to call. So that's a reasonably good technique, and some of the things that you might want to use to choose between number 2 and number 3 is that if you use a generic class, then your business objects need to communicate with that class through a fairly generic data interchange mechanism or data exchange mechanism. The types of parameters that you pass around have to be pretty generic, otherwise you're going to have some very strange looking interface. On the other hand, if you have specific classes that delegate down to a common object, you can create type-safe interfaces for your data objects. And in certain situations, that might be what you want to do. Related to this whole idea of how you end up dividing your objects, or dividing your data objects into some data model, is how do you flow information around the system? When you have a distributed application, where are you going to put the data, and how often do you need to copy it from node to node? You typically want to keep data close to where it's used. Basic stuff, right? Some strategies that you can use to do that. In COM+, there's something called the in-memory database. It's geared for read-mostly or read-only data. And what it lets you do is pull information out of your data store that might be on a separate server and cache it on the middle tier near your business objects. So you keep it near the business objects, it's loaded in process with the business objects, and access to it is very fast. The disadvantage is that there is no distributed cache coordination in version 1, so it's really good for read-only situations, and it can be used in read-mostly situations as long as you don't try to distribute data across multiple nodes. The other thing that you want to do is very carefully design your data exchange. And we're going to go through several options here because there are many, many choices for this. And I think that going through this example in considerable detail will give you an idea of how to make trade-offs between options in other scenarios. Because this is something where there are many choices. So here's a common strategy that gets talked about a lot, and you probably hear it at many of the sessions that you go to. Within an application, pass your data around as ADO disconnected record sets. So that's the record set type, you use it as a parameter, you pass the information around, it gets marshaled by value, all is cool. When you're going between applications, the latest and greatest recommendation is to pass the data as XML. That's nice because there's no dependency in your interfaces on ADO, and there's also no dependency on a particular availability of COM, for example. Your browser does need to be able to support XML, or you do need to have some way of parsing XML, but there's no reliance on COM. And when you need to, you would convert data between XML and the record set format to get it into and out of your application. So some advantages of this are disconnected record sets and XML data don't hold a lock on your data store. That's generally considered a good thing. You don't want to hold long-lived locks. It's easy to program because we have really great tool support for record sets. You can use data binding. It's very easy to use in VB. There's even shortcuts for how to access fields. And it's accessible to script languages all the way up through C++ and whatever you want to use. It also gives you some flexibility in your interface in that you can change the schema definition or change the logical definition of data that you're passing around without having to change the interface that you use to pass the information between objects. And because COM is so strict about the versioning of interfaces, this is a good opportunity to add flexibility. Now there's a drawback to that in that sometimes you can implicitly change the schema without meaning to. So you need to consider whether that's really something that you want to permit in your data exchange strategy. The cons are that you either have to understand record sets or XML. If you don't understand either, you're not going to be able to access the data. It's also not particularly type safe, particularly when you're doing updates. There's nothing that will, in record sets, that will keep you from passing in a bad type of data, and it gets passed all the way down to the data tier before somebody recognizes that that's not the type of data that you need to store in that field. So unless you're doing some business logic level validation of types in the data fields within a record set, you're not getting very good type safety. You're not going to get compile time checking at all. It's also not the most efficient format for passing information around. XML has all those tags, that's kind of wordy. And yeah, you can reduce them, but you got to think about it ahead of time and do the work. And in record sets, it does pass a lot of metadata around describing the format. So it's not totally inefficient, but it's not as efficient as it would be if you just passed the data and assumed knowledge of the structure. These mechanisms tend to break down at large volumes, and I can't give you an exact number of when it breaks down, but as you get up into the, say, thousands or hundreds of thousands of records, you'll probably want to think about whether you use this strategy. For one thing, it passes all the data back in one chunk. So if you've got 1 million records, a disconnected record set is going to try really hard to get all 1 million records back to whoever called it. And that probably isn't what you really want to do. So some options. There are 6 options, and they have various trade-offs. The first is a variant array. You would use a variant array, a safe array of variant arrays, instead of a record set, primarily to eliminate the dependency on ADO. This way you have an interface that has no embedded knowledge of or dependency on the record set type. I have seen varying reports of the relative efficiencies of record sets and variant arrays in terms of transmitting data back and forth. So I'm assuming that it depends a great deal on the amount of data that you're transferring, and hopefully somebody will do some more work on that and get some numbers out that we can look at. I think the worst part of using variant arrays, though, is there's absolutely no type checking. You have to implement all the type checking yourself. And so it's really easy to pass the information along in a format that you're not going to be able to store in the database, for example. And it's not as easy to program, particularly if you're a C++ programmer. Dealing with variants and safe arrays is really a pain. Another option is to use something called the variant record type. In VB, this is exposed as a UDT. This also has no dependency on ADO, but it does have dependencies on particular versions of COM. So that may eliminate that option from your choice. It has reasonably good type safety because you can check specific types within the UDT, but at the moment there's limited tool support. Only VB6 provides support for variant record types at this point. Another option is a conformant array. This is a technique that you would probably use from C++, where you're passing structures around instead of a record set. One of the key reasons you would use this is it has very good type checking. However, it's a little bit harder to use from other languages, so you're primarily going to see this involved when you have clients that are written or can write a client in C++. Another option that you may hear about is something called marshal by value. In this technique, you're actually passing the data back for a particular object when you do the marshalling. So you don't hold an interface pointer, you have all of the data. The disadvantage of this technique is that it requires you to do some extra work to implement the marshalling of the objects yourself. So it's more difficult to implement. But in the hands of a skilled developer, this can be a very powerful technique. And if you've heard that COM+ does not support custom marshaled objects, that's true for objects that are using COM+ services. It doesn't mean that COM+ can't pass those objects around as parameters. So you can provide marshal by value objects as parameters to interfaces that are used in COM+ objects. Now, those are all kind of related to determining the type safety and the relative type safety of your records. Another option that you want to consider is, do you really need to pass all of the information back at once? And so instead of doing that, you might choose to use an iterator. The disadvantage of this technique is that you might have some client applications that start pulling the data back one record at a time. And if they're filling up a page of multiple records, that's a really bad practice. It's going to be very chatty. You also have to provide some server resources or have some server resources dedicated to maintaining the cache of the iterator's data, or you're holding on to database locks. So either way, you're going to have some information cached away that's going to consume some server resources. You can sort of start combining these techniques in something called a smart proxy. The proxy runs in process with the client, and the client sees a simple interface through that proxy. For example, a collection of property-based objects. This makes it very easy for client applications to write their code. And behind the scenes, what the proxy is doing is retrieving data in chunks using a high-performance iterator-type interface. It's very efficient. And optionally, the proxy can do some sort of asynchronous reads, do read ahead or write behind, so that the perceived performance for the client is improved. So those are 7 different options for ways that you can pass data around in your application. How do you pick? Well, some of the things that you should think about are how much data do you need to transfer, and what sort of performance requirements do you have? Think about who the clients are. If you have script clients, that's going to restrict the things that you can do in your interface. If you have clients that are not COM-based, that's going to probably encourage you to use something like XML to pass the data around. And you should also think about how frequently the schema of your data might change, and whether you want to let people get that change without requiring a corresponding change in their code. So are the changes implicit, or do you need explicit code changes in order to react to a schema change? I would encourage you in deciding on a strategy to start with the simplest solution that meets your requirements, and do some experiments to see whether it meets your performance needs. If it does, then stop. Don't bother trying to get to a very complicated scenario if you've got a simple solution that will meet your performance requirements. If it doesn't meet your requirements, then start looking for the bottlenecks, identify them, and then decide whether you need to go to a different solution or whether you can tweak the implementation of the solution that you've picked in order to eliminate those bottlenecks, retest and see whether you've met the performance requirements again, and continue iterating until you achieve the requirements that you need. If you go to the performance talk, that's the story you're going to hear, that you don't try to implement the complicated, fastest solution first, but first take the simple solutions and determine whether they meet your needs before, and do some performance tuning before you go to the complex solutions. So some other example scenarios. This is another question that's come up, and I think it's a real interesting one. We have role-based security on the business layer, and that's really great. You can provide access to, or you can restrict access to particular methods. But typically in your presentation layer, you want to eliminate menu options that aren't applicable to a particular user. There's no concept of roles in the presentation layer. In particular, there's no relationship to the roles that you define in your COM+ application. And for simplicity in maintenance and deployment, you'd really prefer that there only be one set of role assignments. You don't want to have a mapping over here in the presentation layer and another mapping that you have to maintain on the server side. So this is one possible solution. It's not the only solution, but I think it's a reasonable solution, is to define command type methods, methods that correspond to commands that you would find in your UI. You might put these in a facade, and define role-based security per method in COM+. That's a new thing in COM+, is that you can define specific role-based security restrictions on an individual method. Create a component, in this case I've called it access test, that provides a command that you can call from your UI. You only need to call it once, that tests command availability by looking through the COM+ catalog. So it takes the user's identity, searches for what roles that user is a member of, and then looks through the COM+ catalog for the specific command methods that it's been passed, and passes back a set of flags that indicate whether those commands are accessible to that user or not. Once the presentation layer gets that set of flags back, then it can remove options from the UI. Now, if there's not a one-to-one mapping between the UI elements and the commands, then there will need to be another layer of mapping. But hopefully you'll be able to define commands that map one-to-one to methods that you would call from a particular event handler or particular menu option handler, and it will be very easy to turn off particular options from the UI. We're getting close to being done. Disconnected client. This is another scenario that's very common, particularly these days. You want to be able to take your laptop or a handheld PC, something, and do some sort of offline operations. Some of the scenarios that we've talked about are things like an insurance agent might want to take a tablet or a laptop with him in order to do work on policy evaluations, but not be hooked up to their office while they're going off and looking at things. So they want to be able to do data entry and perhaps do updates over time to that data, and then at some point they are going to want to hook back up to the host system, to their main computer system, and load that information onto the primary data stores. So one option that has been presented as a solution to this is to use COM plus queued components. The way that queued components work is that as you make COM method calls, it translates those or marshals them into an MSMQ message, sticks that in a queue, and when the message is pulled out of the queue and you connect back up to the network, then it gets turned into a COM method call and the server side can go ahead and process it. So the disadvantage of that is once you've enqueued a message, there's no way to look at the data. So if you want to be able to permit the user to go back and enter or edit information that they've already entered, then you need some other place to keep the data before you enqueue it, or in addition to enqueuing it. Another option is to use database replication. Keep the data in a local SQL Server database, and then use the data replication facilities to move it over to the main data store. There your issue is, how do you make sure that your business logic is applied? So here's a possible solution. Provide an explicit command to go offline. When you decide to go offline, you download the data that you want and persist it locally. As the user edits information, you would continue to update the local store. And you could use COM plus queued components to enqueue requests to sync up to the local store. When the connection is established, then the server is going to start getting those queued requests for syncs. It can then call back to the client side, create a client side object that would go through the normal online process for handling a particular operation. So this makes sure that you're going through your business logic. Will also make it easier to handle situations like, oh, someone else changed that data too. So it makes it easier to resolve conflicts between multiple updates. And then if you end up with a synchronization request that you've already handled, you've already captured the data, then you just ignore that request until all of the locally persisted data has been moved into your main database. I think this is the last one. Another pattern that is very common is coming up with some way to monitor your application. You need to be able to monitor a running system, and you might also need to be able to provide an audit trail of where you've been and what you've been doing. Unfortunately, there's no standards for how you would go about instrumenting your components to do this. So you're going to need to define your own standards. And that applies not just to the particular interface or particular mechanism you use to do the instrumentation. It also applies to deciding what events or what particular information to provide. And that would be another good thing to standardize within your project. One of the complicating factors is that the technology for logging and monitoring particular things, like do you want to log it to an event log or do you want to log it to a database, that technology that you choose can vary dramatically from implementation or from project to project. And so this is a key place where you can use that pattern of encapsulating variation. Provide a common record event component, the names are arbitrary, with some generic interface that passes in information about the type of thing that you want to record. Perhaps it has a source and a particular type of event and a severity, whatever you want. That event, or that record event component, in turn fires COM plus events to a specific interface. In this case, I've called it iRecordEvent. Now you can implement monitoring components for each specific technology that you choose as an implementation choice for actual logging or monitoring of your application. That component is going to implement the iRecordEvent interface and subscribe to its events. This lets you not only decouple the technology or the implementation of a specific logger from the components that want to provide logging information, but it also lets you have multiple subscribers. So you can pass this information out to multiple sources, And you can use filtering to cut down the number of options or the number of events that you want to record. So for example, you might have a pager component that only gets high priority requests, and it passes those on to system administrators. Okay, so that is a very fast and high-level overview of a number of patterns that I hope you will find useful in your components and in your applications. I want to point you at some resources, and then after that we'll have some time for questions. And there is a microphone somewhere up here in front if you want to ask questions. There is a book called Effective COM. Many of you may have read it. It is an excellent book for giving you patterns that you can use for straight COM programming and MTS programming. Many of those patterns are also applicable for COM+. I mentioned before the D'Souza and Wells book, Objects, Components, and Frameworks. This is a really great book about the process of designing component-based applications. And then there's kind of the standard patterns book, the Gang of Four book. I do have a book that is the kind of introduction book on designing applications, and that's kind of related to what I'm going to talk about on Thursday. But if you're looking for more background information, I don't get royalties, but I encourage you to buy a copy anyway. They might let me write more. The Sean Garland book is an excellent book to give you an overview of software architectures. It's a short book, it's easy to read, and it's very interesting if you're kind of interested in the theory of architecture. And then the Sapersky book about component software is probably the best book that I've seen about just writing components, or the kind of the theory of components, as opposed to, say, for example, object-based technology. These are some websites you can go to. The component design pattern site is kind of interesting. I encourage you to take a look at it. And finally, there is the COM+ resource CD that they are handing out in the back, and there should be plenty for everybody. It has a lot of information about COM+, including a number of presentations that we've done in the past, chapters of books, white papers, and so on. It unfortunately does not have this presentation on it, since I just finished it today, but hopefully a future version will. And with that, I thank you for your attention, and I'll be happy to take questions if you have any. Can I post the slides to the local network? I think they get posted automatically, but I'll make sure that they are posted on the internal site. Go ahead.
I may have missed this in the presentation, but what are the core requirements to use COM+ queued components, NT4, Service Pack 4? Can I write existing component in just COM, or what's the minimum subset?
Okay. All COM+ techniques are Windows 2000 only. We're only providing the COM+ 1.0 services on Windows 2000. To use queued components, your clients need to be Windows 2000 as well as the server. Basic requirements are that your interface has to be in-only parameters, because you can't rely on getting data back. And there is a talk specifically about queued components that is going to go into this in a lot more detail.
Okay, and on Windows 2000, the queued components services that are available there, do they internally use SQL Server, or does that replace MSMQ? Or?
The queued components internally use MSMQ.
Okay, thank you.
Mm-hmm.
I had a question about your recommendation to use like one COM class per logical business entity. What about if you're looking at potentially in a distributed environment and wanting to bundle up a number of these business objects, whether they're as variant arrays or UDTs, whatever? What's a pattern you might use to then, anticipate that for the future?
So this is something where you might want to use the facade pattern to provide a simplified view, or kind of a view of exactly what you want to get back in particular chunks. You can use, there's a facility in ADO to provide sort of nested record sets where you can combine multiple record sets into one and move between them, and that might be an option for you. I'm not sure exactly what the limitations are of using that for disconnected scenarios.
Okay.
So that would be something that you might look at.
Okay, and then just as a follow-up to that, the other thing I guess would be once you get across to these COM objects on the server, then somehow you'd have to be able to have them doing the create instance of the other ones that you...
Right, right.
Okay.
You would need to create the individual objects themselves. But
Okay.
that way you would sort of provide views into your data that are separate from the specific underlying model. Hopefully it would give you some more reusability there.
Okay, thank you.
Can you differentiate a facade from a moniker?
Differentiate a facade from a moniker. Okay, a moniker is used to name something, to name a particular object. It gives you the name to get to a particular type of object or particular object instance. A facade is really just a pattern for providing a simplified interface to a set of functionality. So we should probably talk about what the confusion is and where you're thinking about using it, because they're really kind of used at different points in the process. You want to try again? I'm sorry, I'm not helping very much, am I?
I look at a moniker as being an interface also. I also view a moniker as an interface point. Are you saying that a facade is an interface point?
And a facade is a particular interface. You would define an interface with multiple methods conceivably in a facade. In a moniker, you might encode some knowledge of a particular method to call within the moniker, but typically you would just be providing the name of an object that you wanted to talk to. You wouldn't be defining a set of services to get to. So the facade is really to define a set of services that some particular client or set of clients needs to be able to access.
Okay.
We can talk about it more if you want to.
You said that the state of an object is not maintained across the transaction boundary, correct?
Right.
Is that COM+ or MTS or both?
It's both. So
And-
excuse me, if you are using transactions, then when the root transaction commits, MTS and COM+ will reclaim your object instances, and you cannot rely on the state.
But that doesn't take into account like shared property manager, stuff
Right,
like that.
so shared property manager or objects that are not transactional, that doesn't apply to. Typically what you would do is you would stash the state in the shared property manager or in the client or in a database.
Thanks.
I have a question about monitoring objects. Let's say common goal for monitoring would be very low overhead, so you can use it anywhere you want. And the other thing would be that any failure inside your monitoring system should not bring down your
Right.
application, so it should be loosely coupled.
Right.
What would you recommend to achieve those two goals?
Okay, so the nice thing about, the question is about monitoring objects. You don't want them to slow the system down, and you don't want them to cause failures in and of themselves. So you could make those objects or those particular components non-transactional, or if you required event delivery, then you could make them requires a new transaction. And that would make them independent of the caller's transaction. You could also, if you're using COM+ events, combine that with queued components so that the act of firing the event gets sent to a queue. And then you get immediate return back to the caller, and the delivery of the events onto the various subscribers doesn't block your caller. That will happen asynchronously.
But lightweight often means that even out of proc call is too heavy.
If out of proc is too heavy, then you're going to need to you might not want to use COM+ events, you might not want to use queued components. There is an issue in COM+ where you cannot always use asynchronous or non-blocking calls. And if you can't use asynchronous calls, you're limited to synchronous calls. So in that case, you're going to want to provide probably one specific implementation of your logging component, make it an in-proc component, and instead of using events to decouple them, have that event component run in proc and talk directly to the components that need to provide the logging information. So instead of having COM+ event system in the middle, you would just directly talk from your components to your logging component. And it would be in proc.
But then it's not loosely coupled. Failure in your
Right.
logging component brings down entire app.
Not if you make, well, if it fails to the extent that it crashes, but any in proc component or in proc object that crashes is going to bring down your app. If you want the fault isolation, then you need to make it out of proc. If you're willing to accept in proc possibility of fault failures, then if you make sure that the component is non-transactional or requires new transaction, then it will not cause a failure of the caller's transaction.
Thank you.
My question is related to security.
Uh-huh.
Do you have any, perhaps the resources that you listed at the end, do you have any additional, or what might be the best resource that would explain from an architectural perspective how to get from like components in the business or like the data objects back to the SQL Server database?
Okay, there's a two-part session
Okay.
that is being delivered by, I believe it's being delivered by a guy from IIS, the COM+ team, and the SQL Server team in conjunction.
Okay.
And that is pretty much what they're going to talk about. And the first talk, part one, if I remember right, is about MTS, and part two is new things you can do on Windows 2000.
Okay.
But they're three security experts to
Okay.
nail.
Thank you.
Sure.
Hi. I'm kind of wondering where we're going with the threading models. Of
Uh-huh.
course, on the client side, especially in the GUI area, you're looking at sticking with an STA because of the pump issues.
Right.
And on the middle tier, looking at with MTS, of course, MTS using just departments as well. So, kind of curious as to where we're going with free threaded and some of the other threading models.
Okay. In COM+, which again is Windows 2000 only, there's something new called the neutral apartment. What the neutral apartment means is that objects in the neutral apartment are called on the caller's thread, and they get the synchronization semantics of the caller. You can avoid needing to write synchronization code yourself by using another new service of COM+ called the synchronization service, which basically collects some mutex when you call into an activity, holds some mutex, and then releases it when you call out. So it maintains the activity semantics of MTS, but it does it for neutral components or neutral apartment objects.
Okay.
So there is a caveat to that, which is that right now you cannot implement neutral apartment aware components in VB. So you have to use C++ or Visual J++.
Okay, thanks.
Real basic question. As we move from monolithic apps like an Access application or classic client server VB to SQL Server, trying to go to a true three-tier, if the business layer truly does some work to change the structure of the data, or I want to strictly reflect those three tiers, I haven't figured out how I don't lose the simple end user reporting tools. In other words, how do my business objects expose their data model to a user who wants to use Excel or an
Right.
Access report?
I'm not an expert on all of the reporting tools. I know that if you are using something like record sets, those come back as ADO. So if the tools are supporting ADO, then you'll probably be able to pass the record set into the reporting tool. You can also use data binding on the client side. So anything that supports data binding to some, excuse me, to some data source, you can hook up the record set pointer directly. Excuse me. I'll try again. You can hook up the record set pointer to the data source attribute and then use data binding. So if you have tools that support the data binding facilities of VB6, for example, or IE4 or later, then you'd be able to use that. I think there are some presentations about, more specifically about data, and they may have some better ideas for you. I tend not to run into reporting tools.
Another basic question, if I may. I'm just beginning to dig into XML as a data tool.
Me too.
Cool. Well, I was wondering if you could briefly give me an idea how XML fits in with the COM Plus model. I mean, is it possible to compare it to DCOM or something on that level?
So XML is about data exchange. Provides a way to essentially structure your data in a format that you want to store it. DCOM is more about passing messages back and forth. So typically, an XML data stream might be passed as a parameter in a DCOM method, but they're kind of geared at different things. One is providing the data storage, one is for explicitly triggering actions.
So they're designed to, or not designed, but they're possible to work together then?
Yeah,
XML and DCOM?
you can work together. Typically, the choices right now are you pass the data back as some COM data structure like a record set, or you pass it back as an XML string.
Okay.
And in fact, the XML parser that's provided with IE is COM-based itself. So it's internally creating a COM object model out of the XML stream when it parses it.
Thank you.
Hi, my question probably a little bit special. Is there any way we can intercept the call between the client and server for a DCOM call?
There is no way that you can hook in without providing a separate object that implements the same interface and creating that object and then passing the calls on. We internally use a mechanism called interception in COM Plus to get in the way.
Is that part of the COM API?
No, the interception that we use in COM Plus to provide services is not exposed to developers. So you could possibly use some techniques like aggregation to jump in and hook in, but it would be a complicated thing to do. There have been some articles by the guys from Developmentor about that, so you might check the Developmentor website and see if their samples are out there. It's www.develop.com.
Developer.com?
Yeah.
Yeah, basically the question is that...
they also published some of those articles in MSJ
Yes.
back in January.
Yeah, some of the articles are in MSJ as well.
I think it was January.
Yeah, it's more like COM server. They already have finished their product, like the client called server, but we don't want to do anything on their source code side. We just say if there any way we can create the application jumping in to intercept the call between.
So here's another thing you could do that would be really nasty.
Yeah.
If you know what component they're calling, you know the class IDs of components.
IDL file, you mean?
Well, you have to know the interfaces and the classes of object that they are creating.
Okay.
If you know that, you can sort of sneak in and provide an implementation, point in the registry to your implementation as that class, and then pass it on. There is a mechanism called treat as that I think will do would let you do that. I'm not completely sure that it works for all circumstances.
Yeah, would you tell me the name again? I'm sorry.
Treat as
TREATAS. Yes, it's part of the...
It's part of COM.
Okay.
And it's one of those areas of COM that is somewhat tested. So it might work and it might not.
Okay. All right, thank you.
Hi, I have a question about usually OLTP environment application. Things right now, the 3-tier application, it seems to me the data layer seems to be only storing the metadata and the data, handling the data integrity. But how do you partition your business logic between the store procedures and the middle tier? Because sometimes if you put a lot of stuff in the middle tier, that's actually very slow down the entire process.
Right.
So what is your take on this one? And if I doing a lot of store procedure, actually you talk about the monitoring things you probably can actually put into the store procedure, to triggering using the database to trigger all those,
Right.
monitoring things. So what is your balancing this?
So,
How do you balance
there's
this?
kind of two aspects to it. One
Right.
is if you push the information into stored procedures, then typically stored procedures are specific to a particular database.
Mm-hmm.
So if you're in a situation where you need to potentially support multiple databases, then maybe you don't want to do that. The trade-off is if you want to get really good performance, then very often ways to do that are to shove the information or shove the commands down into the data layer. And yeah, that will give you good performance, so you kind of have to make the balance between them. There's two presentations that you should probably take a look at, because one of them is by a guy from the ADO group.
Mm-hmm.
And when I was looking at his slides, it looked like he was going to talk about this topic.
Oh. Do you have a session?
And do I have the exact
Or
thing? It's like, I'll try to find it, but it's, the guy's first name is Leland, which probably doesn't help you at all. I'll try to find it for you. But it's about ADO performance tuning. And there's another one on COM performance tuning, MTS COM plus performance tuning by Robert Barnes. And I know that in the past, Robert has talked quite a bit about the implications of moving data into stored procedures, or moving processes into stored procedures.
Yeah, okay. And another question that's really related to this, because I tried designing an application web application using XML to marshal to a browser, and we're using the MPS to control a transaction, just whatever right now everybody's saying that.
Stuff.
But the thing seems to me like we usually a web page fetching the data, we actually fetching data and bring up this COM component. Usually we just populated records, the record set to creating a memory, just like COM component, create a memory, populate to the memory, and then convert to XML, send back to the browser, and sometimes you probably just destroy the COM component. So what is the stage? If you maintain too many states, you actually, for each session object, you maintain a lot of server, increase a lot of server overhead. But what is the partition, what is the good cut to for state management, like whether you want to do a very long stay, how do you suggestion to keep a COM component in the session object too long, or?
So I probably wouldn't keep anything in a session object, or try to avoid it, because you are, without very close consideration to your threading concerns, you can end up tying IIS to a particular thread. And you should definitely listen to some of the guys talk about active server page performance and the implications for session objects. In terms of stashing information on the server, that's sort of a cached set of record sets, for example, for common queries. That's something where in COM Plus you might look at using IMDb or the SPAM to keep track of the common record sets, kind of independent of any particular client. And also just think about, is the data going to change? Like, can you pass some information in your URL that goes back and forth that will tell you what set of records to pull out, so that you don't necessarily have to keep the whole record set cached away on the server. Whenever you do any sort of caching, you'll definitely want to provide some sort of timeout. Right, you don't want to tie up the server resources.
Do you really think spam is good? Because 2 days ago, I just removed my spam application.
Yeah, so
because instead using global memory, it seems to me it's much efficient than using
in COM Plus,
spam.
there is a transactional spam that's based on IMDb.
Okay.
That should provide some better performance and transactional protection as well. Otherwise, you have to implement the whole caching scheme yourself, and that's kind of why we're providing IMDb, is to avoid doing that.
Okay, thank you.
In the middle tier and the database tier, the question was, have you done or do you know about any studies for messaging and the patterns of the messaging?
I don't, but there probably are some people here who have. If you can find Elon Caron, I think is how his name is pronounced, He's doing a presentation on MSMQ, and they would be the guys who would know the patterns about messaging. The guy who's doing the presentation on queued components may also have some ideas that are more specific to an MSMQ type solution as well.
Thank you.
Sure.
In your presentation, you were talking about the abstract factory. Is that a service that Complus provides, or is it some kind of design pattern?
Yeah, that's a separate design pattern. You know, the Complus class factory is kind of a standard factory pattern. The abstract, but you do have to specify the type of class that you want to create, right, in your co-create instance call. In this abstract factory pattern, what you're doing is providing another object that contains the knowledge of the specific COM classes that you want to create. So for example, you might have an abstract factory that says something like create customer, create order, but it has...
Is there a way of saying, I am interested in this kind of interface? Can you go and get me the part of the object that has this? I mean, actually what I'm looking after is, you have an object, I mean, a conceptual object that is represented by different data in different places in the world, in different databases and so on. And each of these data have some behavioral, I mean, come with some behavioral and are represented by some interfaces. And what I'm looking after is to create some kind of object server that doesn't know about the behavior of each object. Some kind of like each part of the data goes and say, I represent that kind of behavior, and I present these kind of interfaces on top of my data. And
so you want a map from interface name to implementation class.
Right. I mean, using some kind of aggregation and so on, so that the top object doesn't know very much about what are the different objects that are aggregated and represent the different behaviors of the object. And the caller object just says, well, I'm interested in this kind of interface. Can you go and get me this interface? It's kind of, instead of query interface, is kind of fetch interface or something like that.
We don't have a really good way for mapping from interface to class. You could kind of look at component categories as a way to provide a listing, but essentially you would need to provide the map yourself. And then you could use something like the abstract factory pattern to, given a interface name, pick the specific class that you wanted to implement. And then you could use a delegation model, which is a little bit easier than aggregation and works from COM+ to build up that composite view of the object.
Right. Okay. Thanks.
Okay. Is that it? Are you guys here for the next talk?